Hello, 7th graders. Right now we are doing the warm-up for today's class. Please make sure that you are following along, and anywhere that you had errors without this problem, please make corrections. All right, let's start with number 1. So number 1, we see that we are adding fractions. When we add or subtract fractions, the first thing we need to do is make sure that our denominators are both the same. In this case, we can get both of our denominators the same by multiplying them by one another. So I can multiply 5 by 2 and 2 by 5. Now usually what we want to do though is to get the same denominator, we want to find the smallest value that our denominators can go into. Now what we do to the bottom, we have to do to the top. So I'm going to multiply my 2 by 2 and my 1 by 5. Now there's something a little different about this problem. We have negatives out in front of our fractions. What that means is that our numerator is actually negative. So if this helps you, I would go ahead and I would put that negative sign next to your numerator. All right, now let's go ahead and reset up our problem. So I'm going to reset it up down here. So first of all, I have negative 2 times 2. When I have a negative times a positive number, it's going to give me a negative. So negative 2 times 4 is negative 4 over 5 times 2, which is 10, plus I have negative 1 times 5. When I have a negative times a positive, it's going to give me a negative value. So now I know that negative 1 times 5 is going to give me negative 5 over 2 times 5, which is 10. All right, now that I have my denominators the same, I can go ahead and add my numerators. So now I have negative 4 plus negative 5. Because both of my values are negatives and we're adding them together, first of all, I know that my value is going to be a negative. Also, if I looked at the number line above on the board and I start at negative 4, I'm going to add negative 5. Because I'm adding a negative value, that means I'm going to go to the left 5. After I've counted that, I know that negative 4 plus negative 5 is going to give me negative 9. And then my denominators stay the same for my answer, which is 10. So my answer here is negative 9 over 10. Number 2, I have negative 3/4 minus 2/3. This time we are subtracting this fraction, but let's set it up in a different way. Remember when we have negative values, our negative values mean that they correlate with the numerator. So we can go ahead and erase our negatives and put them in our numerator. Now you're probably thinking, but Miss White, you can't erase the minus sign. What are you doing? Well, we can erase our minus sign and use it for our numerator for 2. And then we add. So instead of subtracting, we're adding our negative. All right, now that we are adding in our fraction, we know that we need to make our denominators the same. To get them the same, we need to find the lowest value that both of these numbers go into, and that is 12. So I know that 4 times 3 gives me 12, and 3 times 4 gives me 12. What I do to the bottom, I have to do to the top. All right, let's go ahead and set up our equation again like we did in number 1. I have negative 3 times 3. A negative times a positive is going to give me a negative value. So negative 3 times 3 is going to give me negative 9 over 4 times 3, which is 12, plus I have negative 2 times 3. When I have a negative times a positive, it's going to give me a negative value. So negative 2 times 3 is going to give me negative 6 over 3 times 4, which is 12. Now, because my denominators are the same, I can go ahead and add my numerators. So I have negative 9 plus negative 6. Because both of our numbers we're using are negative, I know that my value is going to end up negative. Also, if you look at the number line above the board, we start at negative 9. And because we're adding a negative number, we go to the left. In this case, we'll go to the left 6 times. All right, so negative 9 plus negative 6 is negative 15. Over our denominator, which stays the same, and that is 12. All right, I can see that I can even simplify this. So what do 15 and 12 have in common? Well, that is 3. So I can divide them both by 3. Now, I have to remember, though, I have a negative 15 divided by 3. When I have a negative divided by a positive, it's going to give me a negative value. So negative 15 divided by 3 is going to give me negative 5 over 12 divided by 3, which is going to give me 4. Okay. Now, if you wanted to turn this into a mixed number, it would be negative 1 and 1/4. All right, let's go down to number 3. So I have negative 4/9 times 3/8. Remember, when we have a negative out front of a fraction, that means that our numerator is the value that is negative. So I'm going to go erase this, and I'm going to put my negative up here. Now, when we multiply, what we do is we just multiply our numerators and our denominators. That is it. So in this case, I have negative 4 times 3. I have a negative times a positive. I know that a negative times a positive is going to give me a negative value. And so negative 4 times 3 is going to give me negative 12. Over 9 times 8 is 72. Now that I have negative 12 divided by 72, I can go ahead and simplify this. Now, I will tell you that the greatest common factor that these have is 12. So I'm going to divide both of these by 12. Okay, now I have a negative divided by a positive value. A negative divided by a positive is going to give me a negative. And we know that negative 12 divided by 12 is going to give us negative 1. Then I have 72 divided by 12, and that's going to give me 6. So the answer for number 3 is negative 1/6. All right, 4. This is a division problem. So first what we need to do is to remember that because we have a negative sign out in front of one of our fractions, we want to put that and group it with our denominator. Okay, so now I have negative 4/5 divided by 1/3. Now, here is the fun part. Remember, when we divide fractions, we do the dance, okay? We do the keep, change, flip, okay? And try to hold yourself down from doing it and getting too crazy, because I know y'all want to do it right now, okay? So let's go ahead and do the keep, change, flip. So I'm going to keep my first fraction. Then I'm going to change my sign to multiplication, and then I'm going to flip my next fraction. All right, now that we've had this set up, let's go ahead and multiply our numerator, and then we'll multiply our denominator. So I have negative 4 times 3. Because I have a negative times a positive, it's going to give me a negative value. So negative 4 times 3 is 12. Over 5 times 1, which is 5. Perfect. Now, can anything go into 12 and 5? No. So let's go ahead and just turn this into a mixed number. First of all, I know that my mixed number is going to be negative because I have a negative in my numerator. Then I have to think, how many times does 5 go into 12? Well, 5 goes into 12 2 times to give us 10. And from 10, we have 2 left over from our numerator of 12, and then our denominator stays the same, which is 5. If you do not have notes for lesson 17 and 18 completed, that includes the scenario sheet for lesson 17, get out your Chromebook and complete the notes during this time. If you have your notes done, go ahead and start problem set 17 and 18. If you need assistance, follow along with the video as needed. Go ahead and start problem set 17 and problem set 18. If you need assistance, follow along with the video as needed. Right now, the supplies you should have out if you are watching videos is a Chromebook, headphones, and a pencil in your Module 2 note packet. If you are following along with the problem set video, you need to have out your Module 2 packet and open to lesson 17, a pencil, and I would recommend a piece of paper. And then put that piece of loose leaf paper in to your binder when you get finished with it, because there's going to be a lot of work that needs to be shown, and unfortunately on those problem set pages, there's not enough room to complete the work today. All right now you should have your Module 2 packet out, open to problem set 17. And today for 17, we're going to do numbers 2 and 3. For problem set 17, we're really focusing on how to use tape diagrams. So we will be using tape diagrams to solve both of these problems. Let's start off with number 2. Heather works as a waitress at her family's restaurant. She works 2 hours every morning during the breakfast shift and returns to work each evening for the dinner shift. In the last 4 days, she has worked 28 hours. If Heather has worked the same number of hours every evening, how many hours did she work during each dinner shift? So first, let's think about how many hours she worked in the morning. So we have her number of morning hours. And by looking at our problem, we know that her number of morning hours is 2. Okay. And then what about our number of evening hours? Well, do we know that? No, because it's asking us how many evening hours that she worked. So because we don't know that, we're going to use a variable, and we can use E for a variable. Let's go ahead and set up our tape diagram. So first of all, it's asking us how many hours did she work during each shift if Heather worked the same number of hours every evening. So first of all, how many days did she work? Well, it says in the last 4 days. So because she worked 4 days, we are going to create 4 boxes. Great. So we know that all these boxes represent 1 day. So we have day 1, day 2, day 3, and day 4 to represent her 4 days that she worked. Now we need to figure out the value that's going to go inside our boxes. So we are going to want to put the number of hours. Well, first of all, we know that she worked 2 hours in the morning, and then we're going to add how many hours she had in the evening. Because we don't know that right now, we're just going to say plus E. Because we know that 2 plus E is going to give us the total amount of how much hours she worked per day. So let's go ahead and have 2 plus E, 2 plus E, and 2 plus E. Now from our problem, we know that she worked 4 days and she has worked for a total of 28 hours. So we know that our total that represents these 4 boxes is 28. Now let's figure out the total number of hours we know that she has worked. Because we know that she's worked for 4 days and she's worked 2 hours in the morning, we know that 4 times 2 is 8. So now we know that she's worked a total of 8 hours in the morning. So to figure out how many hours she has worked in the evening per day, first of all, we need to look at her total amount of hours. She has 28 hours. And we're going to subtract that by the number of hours she worked in the morning, which was 8. So now I have 28 minus 8, and that's going to give me 20. Now that we know that she has worked a total of 20 hours in the evening, we need to figure out how many hours has she worked in the evening per day. So now I have 20, and I'm going to divide that by 4 because she's worked 1, 2, 3, 4 days. So 20 divided by 4. 20 divided by 4 is going to give me 5. So our question is asking us, how many hours did she work during each dinner shift? Now we know that Heather worked 5 hours in the evening. When we look at our tape diagram, now we know that we have 2 plus 5, 2 plus 5, 2 plus 5, and 2 plus, not multiplying, plus 5. Because I know that 2 plus 5 gives me 7. She works 7 hours every day, and 7 times 4, which is the amount of days she worked, is going to give me 28 hours. Just keep in mind that this is a good way to check your work. All right, let's move on to number 3. Jillian exercises 5 times a week. She runs 3 miles each morning and bikes in the evening. If she exercises a total of 30 miles for the week, how many miles does she bike each evening? So first of all, let's write how much she runs and she bikes. So we know that Jillian runs 3 miles each day. All right, but what we don't know is how much she bikes. So because we are trying to figure out how much she bikes each day, we can use B as our variable. So now we know that she bikes B miles per day. Let's go about setting up our tape diagram. So first of all, how many times a week does she exercise? Well, she exercises 5 times a week. So that kind of indicates to us that she is exercising 5 times per day. So let's go ahead and write a tape diagram with 5 boxes. Great. So now each box is going to represent the 5 days that she exercises a week. So I have day 1, day 2, day 3, day 4, and day 5. Now, what we need to put in as our value in each of these boxes is how many miles she is exercising per day. So first of all, we know that she runs 3 miles every day. So let's go ahead and put 3 in each of our boxes. Plus the amount of miles she bikes. Because that's not given and that's what we're trying to figure out, again, we're going to use our variable b. So each day we have 3 plus b to show us how many miles she is running and biking per day. At this time, we might not know how much miles she's biking per day, but we know that the total miles that she's using to exercise is 30. So we have 30 miles as our total. Now, to find B, what we need to do first is calculate how many miles of running she does per week, because that's what we know. So if she runs 3 miles per day and she exercises 5 times a week or 5 days a week, I'm going to set up 3 times 5. 3 times 5 is going to give me a total of 15 miles that she runs. Now what we need to do is take the total amount of miles that she is exercising per week and subtract it by 15 to figure out how many miles she is biking per week. So now I have 30 minus 15, and that's going to give me 15. Great. Now that we know that she bikes 15 miles a week, we need to take the 15 miles that she's biking per week and divide it by the amount of times that she's exercising. So the amount of times that she's exercising is 5 times a week. So she's exercising 5 days a week. So we're going to take 5 divided by 5. Now I know that 5 divided by 5 is going to give us 3. So now that we know that she bikes 3 miles every evening. So let's go ahead and write down Jillian bikes 3 miles every evening. Okay. All right, to check our work, we can go ahead and go back to our type diagram. Now that we know that B equals 3, I have 3 plus 3, 3 plus 3, 3 plus 3, 3 plus 3, and 3 plus 3. Okay, guys, well, what is 3 plus 3? We know that 3 plus 3 is going to give us 6. And then we have 6 times 5, the amount of days, the amount of time she's exercising. So we know that 6 times 5 is going to give us 30, and again, that equals to the amount of the total that of miles that she is exercising per week. And again, this is just another way to check your work. All right, now we're going to go ahead and start with problem set 18. For 18, we are only doing number 2. So again, take this time to find problem set 18, and then we're going to go ahead and get started. So number 2, a football team scored 3 touchdowns, 3 extra points, and 4 field goals. Let's see what A is asking us to do with the given scenario. It says write an equation to represent the total points the football team scored. So first of all, let's come up with some variables for our touchdown, extra points, and our field goal. We are going to have T equal our number of points for a touchdown we're going to have E equal number of points for the extra point. Okay, and then we're going to have F equal the number of points for a field goal. Okay. So I think that this is a great problem because, you know, we are living in the city of champions right now. Go Chiefs. So for those that also don't know a lot about football, I think that this is a great problem to just kind of like understand how football scoring works. So now that we have our variables written down here, okay, we are going to set up our equation. So our equation is going to look like this. Well, how many touchdowns did the team score? For A, we know that the team scored 3 touchdowns. And we're using T for the amount of points per touchdown. Plus, how many extra points did the team get? Well, they got 3 extra points. So we're using E for the value of their extra points. Plus 4 field goals. So I'm going to have 4F, representing that I have 4 field goals, and F is going to represent my amount of points. Now for B. B kind of seems a little tricky, but in reality, it's just the way the question is worded, so don't be too freaked out about it. It says, write another expression that is equivalent to the one written above. So all it wants us to do is just write another expression here that equals the same thing. So an example for this would be 3T plus 3E plus 2F plus 2F. Now, we can all agree that if we add our two field goals together, it's going to give us 4 field goals, all right, when we combine the like terms of F and 2F, because we know that 2F plus 2F is going to give us 4F. So it's just rewriting out a different way, not too scary. All right, let's go ahead and go to C. So C says, if each touchdown is worth 6 points, each extra point is worth 1 point, and a field goal is worth 3 points, how many total points did the team score? So again, we know now that T for our touchdowns is going to equal 6 points because, guys, in football, a touchdown equals 6 points, all right? And then after you get that touchdown, you can go for that extra point by kicking a field goal. So now I have E equals 1. And then the amount of points for a field goal is 3. So I have F equals 3. Now I'm going to take my equation that I wrote in for A and substitute my values in that I know over here. So now I have 3 times 6 plus 3 times 1 plus 4 times 3. To figure out the team's overall score, what I need to do is I need to multiply these values together first. So I have 3 times 16, that's going to give me 18, plus 3 times 1 is 3, plus 4 times 3 is 12. Then I can add these all together. So I have 18 plus 3, which is going to give me 21. And then I have 21 plus 12, and that is going to give me 33. So now we know that this team's overall score is 33 points. All right, right now, go complete the exit ticket. And if you finish early before the end of class, then you need to get started on video 19 that is due for next class. And this is just a reminder to bring your study guide to the next class from mid-module 2 because we are going to be doing test corrections. On these test corrections, I will be allowing half credit back on all points.